Hello, grade 12. Again, this is an exercise that comes from this book, Engineering Graphics and Design, textbook for grade 12 by Johan Engelbrecht. We are here on chapter 8, development of transition pieces once more. This one looks much easier than that one. So I'd like us to do that one. When you look at my square here, it's a little bit off center. It's off center. It is a square. This side 42, 42, 42, and this is also a square. That is at an angle of 30 degrees. Here is your front view. That is the top view at first angle orthographic projection. So the question says this figure shows the front view and the top view of a transition piece that changes. Draw the following, draw the given views, draw the surface development of the transition piece, show all construction. Right, let's start redrawing it. First, start with our center lines and we'll draw this square box here of 42 millimeters. Then, there we go. Here we'll have my center. Check where it starts from my board. Okay, there. I will have my center here. So I'm taking my center line upwards up to the top view, up to the front view. Now it is a square box. Square is 42. There is my 42, and 42 there. Complete. Oh, I've made a mistake. It's not 42 on this side, it's 21. 42 is 21. This guy makes a mistake. 42 means it's 21. I don't know what I'm thinking. It's 21. You are not nearer to me to assist me. I always make mistakes. So I love my rap. Always make mistakes. Always. There is my 42. But fortunately, if you are a person like me who's erratic, you don't have to be afraid when you have your rapper with you. It's a best friend. As long as you do it correctly, ultimately. Here is my 42. That will be my ground line. I will project the top, the front view. I'll project the front view up there. I'll have my front view. Anyway, I may just as well put my ground line here. And then it tells me I can make it solid then. This side I'm sure of it now. This line is not there. Hello? Don't lose me, guys. I'm with you. Now, we have that height of 42. 42 is that height, and then we have this square that is at an angle of 30 degrees. So let's take the height first. I like taking the easier ones first. 42 gives me confidence once I've tackle the easier one. 42 will be somewhere there. I know that will be the height of my transition piece. The base will be here. Now I have to deal now with this 22 square that is off center. Since it is a square, I may just write a circle around it of 22 millimeters. So the circle of 22 millimeters diameter is a radius of 11. Take my radius 11, right at the center, very faintly. Do that. This is for my construction. Then at an angle of 30 degrees, because I said it is at an angle of 30 degrees, there is 30 degrees there. Tangentially, I will do that. I will do that tangentially, and then I will do there very faintly, just to make sure that I've done the right thing. They said it is 22. Let me check. It's a 22. Voila, that's 22. That is 22. Now I'm confident that I've done the right thing. Bam, then I can make it solid. Then I can make it solid as a rock. That was the trick. Now I have drawn it now, projecting my top view. My front view, no, it's first angle, it's front view, and there, that line there, and there will be that line there, and that other corner there. I know these two, they will go down up until here. There we are, they'll go down up until here. Good. Right, let's check how we've drawn it. Now, this corner goes up there, that there, from, where is that? That is a seam. Your seam will be that corner. And then this one is that one, to go up there. Then this one will be that one. Let's try and do that. This one, I'm saying this one here, so up there is the one that will also go down there. Check again. Yes, it is that one. There. And at the same time it will go down there. And then you will finish it off by, not yet off. We'll draw our seam. Our seam is there. There is our seam there. Good. Now we have redrawn it, but now we develop. This is the top part. Maybe I'll call it 1, 2, 3. This corner's 4, which means that corner there is 1. This one behind there is 2. This one will be 3. There is 3. And that one that is nearer to me will be 4. And then the base, I will say A, B, C, D. I'll call that part K. where the seam is. The seam is a 2, call it K. At the bottom, there my K is. At the bottom, there is my K. It is there. Now, once more, we'll use a method of triangulation when we try to develop this surface area of this component. So because we are starting here, 2 to K. Now, 2 to K is not parallel to the ground line. I like drawing the ground line. It's not parallel to the ground line. Even on that side, 2 to K, 2 to K, 2 to K is not parallel to the ground line. So we rotate one of them and make it parallel to the ground line. In this case, I will rotate 2. I will rotate 2. Where is my 2? From K, I will rotate 2 towards here, taking 2 there, away from where it was. Hey, hello 2. There, I've rotated 2. 2 is now there, and then as I project, my 2 will be here. My 2 will be here. It's no longer here, it's here, the true length, that true length. So, sometimes others will find they will write the length of 2K, the length of 2K being this one. That is the length of 2K. They will put it aside, maybe they write it here. But with me it's fine. I will leave it there and say that length. I will just identify it as TL, true length of this line. Maybe I mark it with a 0. Mark that line with a 0. I've identified it as the true length of that line with this marked 0. So that's true length. There we are with that true length. With me, I will start developing right away. Like this. On the inside, I will have 2, 3, 4, 5. So it will be 2 here, and then K will be on the outside. There will be my K. My K is there. There's my K. My K is there. So that is my first line of development. Now I must move from K to B. K to B. Where is K? Alright. When we look at it from the top, the base part, from the front, you are seeing D. Behind D, you are seeing D. Behind D, there is A. You are seeing C. Behind C, there is B. Here, behind this line, there is K. K is on the other side. Now, let's continue. Now, we are going to move from K to B. K to B, parallel to the ground line, which means K to B is the true length. K to B is the true length. Now, let's take the true length from K to B. It really is the true length. There is it, K to B, because it is parallel on one side to the ground line. So from K to B is the true length. K to B is the true length. Now, I must move now from 2 to B. 2 to B, that is why now we do the fold lines. We use the methods called triangulation. We form triangle. I construct this line. It is a constructed line so that I have a triangle. And then I will also join B there with another triangle that will go there. Join that with a triangle. Now, I must move now from 2 and find B. 2 to B. That true length I do not have. 2 to B, I do not have that true length. So I mark it X maybe. Say mark it X. That true length, so we're going to look at, going to name it X. We name it X at this time. Now, where do I find my X? 2 to B. Where is 2? There is 2. 2 to B. 2 to B is not the true length. It's not parallel to the ground line. 2 to B, it's not parallel to the ground line. So we'll rotate one line segment and make it parallel to the ground line. So I will rotate, because it's 2 to B. In this case, just for fun, I will rotate B. I will rotate B. There is B, making it parallel to the ground line. How do I do that? I've done that. Here is it. I've rotated B. B from here, and then I project up. I know the line that I have rotated is B. So now B is here. Now it's no longer there. It has moved slightly to be here. Now from 2, for you to see, just for you to see, it's meant for you, this coloring. From this one to that one, it is the true length of 2B. That is the true length of 2B. The one that is marked X. So that is the true length of 2B. So let's do it. Let's transfer it. There is the true length of 2B. 2B. The true length of 2B. There is that one. So now from 2, I find B somewhere there. 2B. B is there. So that will be my B. My B will be here. That will be my B here. And then from B, before I go to C, I must now move from 2 to 3. 2 to 3. Look at it there. 2 to 3. 2 to 3 is parallel to the ground line. So this line is the true length. 2 to B is the true length. So let's take it. Let's take it as it is. It is the true length. 2 to B. I'm saying 2 to 3. I want to say 2 to 3. From 2, I'm going to look for 3. 3 is going to be somewhere there. Anywhere here. 2. But now I must now move from 3 to B. I'm using these triangles, my method that I'm tracing. Now I must move from B to 3. When I look at B to 3, there is B to 3, B to 3. B to 3 is not parallel to the ground line. And B to 3 is not parallel to the ground line. So we will rotate 1. So I decided I'm going to rotate, in this case, I'm going to rotate B. Let me rotate B. There was my B. I'm rotating my B. I'm making it now parallel to the ground line. I've rotated B with my T-square. It will be somewhere there. And then I take it up. That is the B that I have moved now. B, I have moved it to here now. So what is that true length? 3 has not moved. Only B has moved. Only B has moved. Now, that 3. So this one is the true length of 3B. 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 But for us not to forget it, I will mark it as 1, like this. Roman figure 1. Roman figure 1. So that you know this one, I'm referring to that line as the true length. Even this one is the true length. Those are true lengths. and this one is also indicated as the true length, this one. Now nayo masifake i-red nyana, sifake istayela at least ukuthi I'm referring it to a different line, just sazi ukuthi na elias imark is 0, the one that is marked 0, it is also the true length. Now this one is the true length of 3b. Now I must move from b to 3. I will take that true length from b to 3. From b to 3, there we are. B to 3 is this one, but its true length is this one, b to 3, the real length. Now that is b to 3. So we will locate our 3 here. That will be our 3 there. So that's our 3 here. And then from 3, you are going to go to 4. But from 3, let's go to C. From 3 to C. So we triangulate it. We form a triangle. Construct a triangle there. So that from 3CB is a triangle. So we must go and find out the true length of 3C. There is 3, there is C. 3C is not parallel to the ground line. 3C is not parallel to the ground line. So we rotate one. So in this case, I will rotate 3. If I rotate 3, it will be somewhere on that other side. Let me do that. Talking about 3C now. 3C. You can rotate either one. I changed my mind. I just want to rotate. I just want to rotate C. I'm rotating it. Then it's now here, parallel to the ground line. C is now parallel to the ground line. And I transfer it there. So my C will be here. 3 is there. 3C will be that true length. Let me write it, that true length, 3C. That true length is 3C. But which one? This one I will name it like that. It will be like that. So the true length of that one is that one. Let's take it, boy. Let's take it. What is the true length from 3 to C? That is the true length from 3 to C. Now from 3 to C, there is that true length. From 3, I'm gonna find my C somewhere there. 3C. But now I must move now from B to C on the outside, from B to C. If I move from B to C, BC is a point view. There it is. BC is a point, 1 point. BC is a point view, which means AB, or say BC. You see them from 1 point. So on the other side, you are seeing the true length. So this side will be the true length. BC will be the true length. Now here is CB. CB, BC, CB, BC, CB, and then there is BC. B to C is there. So my C will be located there. That will be my C. Then I would like to join without even wasting time. Let me join it. from C, I will go to D. But now from C, I've gone to 3 already. I've done that. From C to 3, that fold line is there. That is the fold line. That was the triangle that I had. That was because we're using a method of triangulation. Those were my fold lines. Now I must move now from 3 to C. That's where I can end up out. But now I'll move from 3 to 4. 3 to 4. Let's look. 3 to 4 parallel to the ground line. 3 to 4 is parallel to the ground line. That is also the true length. Parallel to the ground line, we are having the true length. 3 to 4 is the true length. Now, we need now to move from C to 4. From C to 4. So let's construct a fold line there. From C to 4. There is a fold line from C to 4. That will be a C to 4 fold line. And then when you look at this fold line, it's amazing to notice that this one from C to 4 is the same. Is the same. This one, this fold line will be the same as that one. This fold line, this line segment is the same as that one because it is at the center here. Remember when we constructed this circle and we did this tangential, but this side, this will be the same. But if you have doubt, we can prove it to you that they are the same. Look at 3B, and then I will do CB just as a proof for you, to show you that I made to believe that they are the same. They are the same. So look at 4C. 4C. If I rotate 4 and put it here, I'll be rotating 4. It's put there, and as I project, 4 is there. As I project 4, my 4 will be there. There will be my new 4. 4C. Let's check. There is C. There is my new 4. 4C. And I said it is the same as that one with the 1. Let's check. Look. They are the same. This one and that one. So 3B is the same as 4C. So I mark it. They are the same. Interact with your teacher and whatever. Use your mathematical methods, geometrical methods to verify what I've just said. You will see. There is my 4C fold line. There is that one will be the fold line, and then this will be my 4. This will be my 4. And then from 4, you must go to D. 4D. 4 goes to D. When you go for 4D, there is 4D. For 4D, it will be this one. This one will be for 4D. Verify that this one will be equals to that one, 4D. It will be equals to 4D. 4D from 4 to D. This one. 4D. I open it a little bit. It gives me 4D. D will be somewhere here. D will be somewhere here. And I must move from C to D. CD, true length. C to D, it is the true length. 4D is there. So from C to D, that will be your true length there. That will be your true length. Then you join. Once you join, there is your fold line. There is a fold line. That is your D. This is your D. From D you'll move to A. From D you'll move to A. From D to A you still have the same measurement. Because it is a square, you will have the same measurement, Majid. Yeah, same measurement. There. Now from D to A. A will be somewhere here. Come to look for A somewhere there. Find A there. But now instead we must now move from 4 to 1. 4 to 1. 4 to 1 is the same size. 4 to 1 true length. 1 and 4, 1 and 4 parallel to the ground line, true length. 1 and 4 true length. Now I must move from D to 4. From D to 4 is this one. From D to 4 is this one. Oh, D to 4 is already there. Now I'm looking for, from 4 I must go to 1. Now I must move from 1 to D. From 1 to D. 1 to D. I put in another fold line here. That will help me to go from 1 to D. Fold line there. And that fold line, let me check. It must be equal to someone. This one will be equals to that one. It will be equals to this one. Or this, that, because it's a square. It will be equals to that one. 4D, 1D, D1, 1D, D1 is this one. D21 is there. That is my 1. My 1 is here. Now I must move from 1 to from my 1 to A. A is somewhere here. Now I must move from 1 to A. 1 to A. 1 to A. 1 to A will be that one. 1 to A will be that one. 1 to A, this and that are the same line. 1 to A is that one. 1 to A is going to be there. Which tells me that my A is here. You don't need to spend more time here. I'm spending too much time because I'm trying to be as slow as possible to cater for most of the learners. This is the fold line to 1, very faintly, and then this one, it was also connected to D, very faintly. This one, the outside line, it's solid. This is what we have. And then now we move from 1. From 1, we go back to 2. 1 to 2. We started at 2, now we go back from 1 to 2. From 1 to 2, we still get the same. It's the true length. I'm not going to explain it any further there. You know why. And then from A to 2, where is A? And then A to 2, A to 2. We'll make that fold line there. That takes us from A to 2. From A to 2. That one that takes us from A to 2 is this one. Is this one. From A to 2. Where did I do? What did I do? No. This one is that one. Is that one. It is that one. It is that one. From 4 to D is that one. From 4 to D is that one. And then, from 4, let's check. From 4 to D. 4 to D. 4 to D is X. Is that one? How did I miss it? From 4 to D is this one. Let's check. 4 to D is that one. From 4 to D is that one. Yeah, no, I got it right. I don't know, maybe they are the same. I was redoing one and the same thing. Yeah, I mean this one and that one, I think they are the same. Nevertheless, if you are not sure, it's better to have more true lengths than having less, as long as you've got the correct length for that one. 4 to D is the same. This line, X, and this line with the 2's like that, they are the same. They are the same. They are this, that, they are the same. All of them. Yeah, all of them. I've made more. It's a duplication what I've done here. This and that are the same. That and that, they are the same. They are the same. They are the same. I should have done it once, but nevertheless I've done it twice. It's okay. If you are not quite sure, you just do the true length and then you'll see after you've done it whether they are the same or not. Now, from 1 to A, I have that. Now I must move from A to 2. From A to 2, yeah. A to 2. A to 2 is the same true length as that one. A to 2. Same thing, the stuff here. A to 2. A to 2. A to chow. A to chow. Fold line. There is my 2. Solid line here. Now, there's one piece that is left now. From 2, we have A to 1. Check. A to 1, I've done that. A to 1. A to 2. A to 2. What am I doing? Let's check. From A to 2. From A to 2, this one, it will be that one, that line. From A to 2. Sorry if I've confused you. From A to 2, it is this one. From A to 2, what is it? It is that line. It is that line that I have marked. From A to 2. From A to 2, it is this one. From A to 2, it will be that one. So my 2 will be here. My 2 will be here. From A to 2, it will be that one. I've made a mistake. I acknowledge. Then I remove that 2 there. I remove that piece there. My apologies. My apologies. There is 1. From 1 to 2, boy, come on. 1 to 2 is this guy. Same distance there. There is 1 to 2. Check. Yeah, it's that distance. 1 to 2 will be here. Okay. Make sure that your rubber is clean. I will clean rubber. 1 to 2 is there. And then D to A. Obviously, I think I got it right. That one, D to A is the true length because it's the point view. D to A there, yeah, it was that. There is my A. Now from my A to 2, A to 2. A to 2 is the one that is marked 1. A to 2 is this one. A to 2 is that one. A to 2, it will be here. A to 2. So I will have my 2 here. 2. Now I must move. That was A22. There was A21 is the forward line. Now I must move from A to 2 is there. I must now move from A to K. A to K is parallel to the ground line. A to K is the true length. 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 There is that true length of A to K. Now I must move from 2 to K. From 2 to K, let's check. 2 to K is the one that I've marked 0. That is the true length there. There is it. A to 2. There we are. It's there. So this is it. It ends there, guys. Started with 2 to K, it ends with 2 to K. That is A. Yeah. Although I made some mistake, but fortunately I did find my mistakes with this true length is the same true length. So if you are not sure whether this one is the true length or not, just construct that true length. No marks will be deducted for having another true length of which it is the actual true length. As long as it is there, guys, it's okay. I think and hope that you understood what basically we did here. We thank you and have a nice day.